All right, excellent, excellent, thank you. Hey, I couldn't resist after that video. A couple things came to mind. Number one, we love boat racing too and love to be into the fray there, so I changed my background for that. You know, I had a conversation about that. I think they're turning this way. So a little bit of background about myself. My own background is from cloud business. So I come from AWS before Oracle, where I worked for 3 years as a business development manager. Previous to that, almost 17 at Microsoft, where I helped with Azure and Windows Server business. So very familiar with Altair, very familiar with the Oracle business as well. It's great to be here talking today. So a little bit about our team. Like myself, there's over 600 engineers, mainly in the Seattle office now, that are all have come together in order to build a next generation of cloud infrastructure. And the engineers are, this is our second generation of cloud. Our leader is Don Johnson. He came from AWS. He was in charge of S3, the first AWS service, worked there for 10 years. And we were given this challenge of saying, okay, knowing what you know now after building out AWS, after building out Azure, how would you build the next generation of cloud for Oracle? Oracle has an existing infrastructure. We're on a $1 billion per quarter run rate right now. How would you build out a new IaaS infrastructure, knowing what you know now moving forward? So that was a challenge 2 years ago with 5 engineers. Today, we're over 600 engineers and that have organically grown. These are all engineers in the Seattle office, pretty much, where AWS is 4 blocks away from us. Azure is right across the lake. Google Cloud Compute is right across another lake. So we're all right there within a couple miles of each other, and there just seems to be this center of excellence. Because of that, the Seattle area is growing. I don't know if you're familiar with it. But right now there's more cranes in Seattle than any other town in the country, according to a recent Forbes article, and it's a boom town. So as this new computing paradigm has shifted from mainframe to mini to micro to cloud, the center of excellence seems to be moving into a particular area where these engineers have this expertise. All of us are passionate about building out this new infrastructure. Compute, network, storage primitives that are callable through scripts. They can instantly instantiate and be able to use. So we're here in order to take our decades-long history with Oracle in the enterprise market now, focusing on the enterprise and coming on down in order to build a truly great cloud. So that's kind of the background, a little bit about our story here. We just launched Oracle Bare Metal Cloud Services last fall. Since then, we've iterated on the product. Last week, we opened up a new region in Virginia. We have multiple regions that are coming online, so this is a sprint that this team is doing, so it's a lot of fun. Let me talk a little bit about our value prop. I'm going to net it out. We're engineers in this room, so I'm going to put it on one slide. We're building out a next generation of cloud infrastructure, and really at the top level, it's around enterprise. We're starting with the enterprise first and providing flexibility that enterprises need, and then price performance. We believe that we have economies of scale because of our Sun business. This is all built on Sun hardware. And then on the performance side, we have some real advantages for enterprise-type workloads. Specifically, we are providing bare metal instances. So when you vend out a server from our cloud infrastructure, you can opt to be getting an entire bare metal instance. 36 cores, 72 threads, a half a terabyte of RAM, 28 terabytes of storage in VME, which is vended out to you and you can start using it in under 5 minutes. No hypervisor overhead. So there's some real performance advantages for HPC workloads in that type of environment. Okay, so let me talk a little bit about the first focus area around enterprise flexibility. This is internet scale-out architecture. It's a particular style, a cloud architecture style that AWS really invented. But it's internet native. So we're using this internet scale-out architecture. It supports constructs such as HPC, big data, objects, as well as containers. But we're combining that with also enterprise scale-up types of capabilities. So being able to instantiate a bare metal instance, to be able to use that as well as VMs. NVMe storage, I don't know if you're familiar with it. These are new super fast SSDs connected through PCIe interfaces that provide an order of magnitude faster performance than SSDs alone. Rack, Exadata, these are engineered systems for the database part. So these two things come together. we're on the flexibility part. This is really around being able to vend out bare metal instances as well as virtual machines or containers. So we're providing that type of flexibility in an app deployment model. And then on the security front, there are some advantages in security. Oracle's first customer was the NSA. So security is kind of deep within the roots of our company. And there is no host code that's required. So if you if you receive a bare metal instance, that's what you want to run, there's no Oracle code that's on that machine. Zero. You have full control of that stack. And that's unique within the industry. There are some edge cases where there are some hypervisor vulnerabilities. There are edge cases. This deals away with that. And then around governance and control. Large companies have multiple departments, and there's something called account sprawl that's happening in other environments. We created a system which allows a single company to have compartments for each of their departments, if you will. And I think of this as a compartment is to a data center, as a subdirectory is to a hard drive. It's a way of organizing resources, but rather than just files, it's compute, network, and storage. Okay, so that's the first part of it. The second is around price. We are the lowest cost provider of compute. On average, we're around a third less expensive than AWS on compute. On network, we're 86% less than AWS. They charge in 4 different dimensions. We charge in 1, and then in that 1 dimension, overall, we're 86% less, and that's that's before the first 10 terabytes a month are free. So we believe that there's a lot of money that is margin that's in the compute and networking area, and we're lowering that price point dramatically. On the storage front, we're 50% less than AWS's EBS block storage, and we now scale 26,000 IOPS for that half the price. So there's a price performance advantage in storage that's very real. Uses the same model, pay as you go, no CapEx, 100% operational expense. You can use it for an hour, and one of those servers is $5 an hour, $5.40 an hour, that's it. Or you could use it for a day. It costs the exact same amount to launch 1,000 servers and run it for 1 hour as it does to run 1 server for 1,000 hours. And in this business, that's a big deal. It gives you that flexibility. And then we have steep discounts for monthly commits. So if you know what you're going to be using and can commit to that, those prices drop dramatically. On the performance side, there's some advantages around bare metal. No hypervisor dependency. You can run a VM, we offer it, but you don't have to. That's unique. And that means it's a smaller stack size, smaller surface area for attack, etc. The storage, 11 times faster than SSDs. That I/O performance can be very advantageous when you have I/O perform workloads. Bare metal provides this predictable performance. One of the things that we have seen is that there are no noisy neighbors in this environment. If you're bare metal, there's nobody else sharing that host, and it's a dedicated network. So that variability goes away. If somebody's running payroll while you're trying to run a job, that doesn't impact you because you have your own environment. And then all this is done through, I call it code-defined infrastructure. These are scripts using either RESTful APIs or SDK or a CLI to be able to deploy. So as an example, we can set up a network across 3 availability domains. Those are 3 different data centers. This would be one data center we're in right now. Another one would be across the town, in a different power grid floodplain, and a third one would be in another section of town. That's the way that our design architecture works. And we can set up a network and start using it in under 5 seconds. So rather than showing a video, which I've seen to be problematic in this forum, what I thought I'd do is just show it because it'd be a little bit easier that way. So here's what I'm going to show. I'm going to show exactly that. We're going to set up a data center. So on 3 different data centers, ADs 1, 2, and 3, we're going to set up a compartment. And in that compartment, set up a network. In that network, we'll set up an internet gateway and then set up subnets in each of those 3 networks in under 5 seconds. And then what we'd like to do after that is we'd like to launch some servers. I'll launch 1 or 2, maybe 3 servers in those ADs, and then create a block volume and attach it. And then log into that running instance and start to use it. And if there's not questions, it's typically under 5 minutes. So that's what I like to show. I'll go ahead and click on here. Our challenge is going to be, will this show up this way? Looks pretty big. How does that look? All right. So this is our login screen. I'll go ahead and sign in. And my apologies for the real estate. The projector is pretty low res. And this is telling us that we're in the Phoenix region here. Okay, and so this is the console. Here we have, across the top here, we have compute, network, storage, database. Let me go to networking. And I wanted to create a virtual cloud network and 3 data centers in 5 seconds. So let's do that. This is the compartment called Quick Start. This is the name of the network. I'm going to have to type while holding this. I'm not sure how well that's going to work.
The other mics might work.
Can these work okay? Test, test. All righty. And what I'm going to do is I'm going to create this, network. I'll call it PBS Works. And you can see it sets up the DNS name. There's our internet gateway. There are the subnets and 1, 2, 3 different data centers. I'll hit create, 1001, 1002. All right, so it took a little bit over 2 seconds. And what that's a lot faster than running the cables. And that's because it's all, but we physically just created that network. And I'll go ahead and drill into this a little bit so we can see it. We'll view the cloud networks here. You can see the CIDR block. You can see there are the 3 different data centers. And you can see here the details behind it. Okay, so there's a network. Now that we have a network, let's launch an instance. So I'll just go to the instances, launch instance, and I'll call this server 1. And here it says, which of those 3 data centers do you want to launch in? I'll say AD3. I always pick the 3rd. What image, what software do you want to use? And here I could say, here I can connect, say, Canonical, CentOS, our own Red Hat version of Linux. Here is a Windows Server, or a custom image. For example, here I've set up PBS Works already. For this one, I'm going to just select CentOS as an example. Shape. What shape is how much hardware do you want? Here I have, under the shape, I have a standard instance that's 36 cores, 72 threads, no hard drive. This one has 512 gig, 36 cores, and it has 12 terabytes of NVMe. This one is the same, only has 28 terabytes of NVMe. Or we could use virtual machines, 1, 2, 4, 8, or 16 core. I'll just pick 4 core. And here it's asking which network. I want to launch it in that PBS Works network we just set up together. And let's see here, it asked me for my SSH keys. So I'll paste those in there and hit launch. Looks like I forgot to say, oh, subnet, there we go. There we go. I know I skipped something, and hit launch. So you can see it's live. Now it's a VM, it'll take about 44 seconds. I can launch another instance. I said I'd launch 1 or 2. We'll call this one server 2, we'll put it in AD2. And this image, CentOS again, and PBS Works network. And the shape, let me launch like a bare metal high I/O instance. That's a bare metal machine. That'll take about 4 minutes to launch. We might not have a chance to log into it. I'll put it on the same network, but it is going to be in the second domain. I'll paste my keys in there and hit launch. And so another instance is launching. Okay, so while those come up, I'll come over to storage. Block volumes here. Excuse me. What I'd like to do is create a block volume. Excuse me. The name of this, we'll call this vol1. And we'll put it in AD3. It's always good to put your volume in the same data center as your compute node. Here you can dial up or down the size of that volume. I'll just say a terabyte and hit create. And so now it's provisioning that block volume. It'll take about 6 seconds in order to do it. And while that's coming up, let me come to object storage. This is our object store where you do backups. I'm going to create a bucket called my bucket. And I can drill into this new object store, say view bucket, and here I can say let's upload something. I'll just say browse my machine. I'll just take a screenshot and hit upload. And bam, it's uploaded. So there's a block and object. Let me come back here to compute node into those instances. You can see that virtual machine is now up and running. What I'd like to do is I'd like to view the instance details. And let's attach that block volume we just made. Vol1, and hit attach. Bam, and that'll take about 5 seconds to attach that volume. And now that we have that last step here, I said I'd log into that running instance. Here is the public IP address. We're going to go through that internet gateway in order to log into it. I'll start, whoa. Got to get my terminal so you can see it. Nope. Just having a. Yeah, I think that is a problem. Let me try one more time here. Yeah, there we go. So there we go. There's our terminal. What I'd like to do is paste this in the IP address, so that running instance I just copied. Yes. And LSCPU, let's see what that is. You can see that has four cores system that is now running. So you can CPU is 4 cores, single threaded. It is a Xeon processor, 2.3 gigahertz system right now. Yeah, so you can see, there you go. Ta-da! All right, so let me get back to out of this and back into PowerPoint. Sometimes it's easier just to see this stuff rather than PowerPoint yet, but I did want to just show you that example. So that's what we just did. Price performance. When we launched in fall, we had a nice price performance advantage. On the compute part of it, we launched our high I/O instance. That's that bare metal instance I just showed you. Twice the cores, twice the RAM, 11 times the IOPS performance, and 4 times as much storage than AWS's comparable i2 at 21% less. That was a nice feature. Since then, AWS came back and they introduced the i3 family recently, so we're pushing them, which is a good place to be. But we are still 16% less. We have more cores, more RAM, yet we're still 16% less than that high I/O image. On storage, we're 33, or excuse me, on a VM machine, that VM that I logged into, we're 33% less list to list than AWS before discounts. And then with network traffic egress, we're 86% less with fast environments. At AWS, I could never set up a network, and here's an example of being able to set it up in 5 seconds. So anyway, that's the overall. Some test case scenarios that we're targeting here. High performance computing, obviously, general purpose HPC type of computing workloads. Big data analytics, those are some areas where bare metal really is helpful. Another place is Oracle Enterprise Apps. 1 minute, okay. And so, and then cloud native applications. And let me skip through here. A couple customers that are using the system today. This is interactive or analytics, big data workloads, visual analytics. And then finally, Altair and Oracle announced a relationship earlier this year, and where PBS Works is our preferred platform for doing HPC computing on the Oracle Cloud. So we're super excited about this relationship. We did some benchmarks there. Basically, it's showing that on the benchmarks, we're showing that we're able to run in a linear fashion some workloads that in some are more I/O bound, where the network at 10 gigabytes is limiting us. The good news is our roadmap is to shortly go to 25 gig networks, and then we'll have 2 25 gig network connections, one for host to host, one for host to server, or storage, excuse me. So that's coming shortly, about September timeframe. So that will be nice. This is a couple benchmarks here. This is a car crash one, which basically indicates we use 8 nodes, 36 cores each, and acceptable scaling with 10 gig, low latency under 100 microseconds round trip time. And performance is similar to HyperWorks Unlimited. In this workload, this is comparable workload. This one uses that NVMe storage. Performance is comparable to on-prem systems connected with 10 gig. When we get to 25 and 50 gigs, I think that will really allow it to breathe. An example customer that we're working with in the oil and gas industry, this is a deployment. They are deploying in Houston, Texas area. And you can see here's the 3 data centers, 1, 2, 3 that we set up in the cloud. They're running right now around 60, well, it's 4,000 threads that are running in bare metal cloud services using PBS Pro for job scheduling across those nodes. That will scale up to 30,000 threads. So yeah, that's a quick overview. Call to action here, ask for a free trial. It's super easy to launch this stuff and actually use it. We're making compute, network, and storage very easy and approachable and inexpensive to use. That's our goal. And ask for a trial. You go through a tutorial, launch some instances as I just did. And if you like, give me a call. Shout out, my email is there. Let's get a pilot going in your environment. Be happy to do so. There you go.
While folks are coming up and we're changing over, maybe there's time for one question. Well, if anybody has one. Otherwise, I'm going to ask the product management team to come up for the panel. Anybody else?
You have any plans to include InfiniBand?
Yes, InfiniBand. So we do have InfiniBand support today for our database shapes. So we have the question was InfiniBand support. So we do have InfiniBand today. I could have launched a database instance, which does have InfiniBand, either 2-node rack or else a Exadata quarter, half, or full rack. So we can launch those on demand, just like I launched the bare metal or virtual machine instance. You can launch a database. It is something we're looking at. The question is once we get to 50 gigabit network speeds, do we need InfiniBand? I don't know. Maybe a question for you guys. But we do have the hardware for one workload now. It's something that we're thinking about, but it's not clear yet if the demand side of that.
No, you don't want to ask? You don't want to ask? You were reaching out. Oh, okay. Oh, okay. Get him later. All right. Thank you again.
Okay, you bet.